All right, guys, sorry I had to take a pause real quick for a second there. All right, so we know we have our voltage and we know our grounds are good. We have voltage on both sides of the orange wire. All right, so which is good. So that's our power off our circuit breaker or our fuse. So now we're going to check the white wire because we look it up. Seat forward and backward is going to be white and brown. So we check our voltage here. Okay, so I have voltage in reverse position on white. All right, so reverse is working on both sides here. All right, so now we want to check brown. Brown should be forward. All right, both sides. All right, so all our wires are working. The problem is brown should be working like white works, right? So white, if I pull it back, I'm getting voltage on both of the wires in the same position. But on brown, I'm getting nothing in one position, and I'm getting voltage in the reverse position where brown should be forward, not reverse. Okay? So now I know I have a problem on my brown wire side. So now what I want to do is I want to look at resistance on our brown line, which is 265. All right? What is my resistance on the white wire? All right, 0.5. 0.5 on both sides coming off of ground, right? So we know because these motors are grounded to the frame, so we're good there. What am I on the brown side? 0.3 and 1.5 ohms of resistance, right? So since everything else is 5.5 or 0.3, 1.3 ohms of resistance would be considered high resistance. If you want to double check those resistance, go across your brown leads here, all right? If you had the harness open, you're looking at 1.6 ohms of resistance across your 265 wire, but yet you're only seeing 0.4 ohms of resistance across your 294 wire. So you have high resistance on the brown side. So the important thing to remember about that is when resistance goes up, voltage stays the same, but current always goes down. So your problem would be in the brown wire. Now the problem would be, where is this resistance being created? Is the switch a little corroded inside and that's causing resistance enough to shut the circuit down, or is resistance in the motor, right? If you had resistance in the motor, what would happen is this motor is not going to go forward or reverse. It's actually locked up, all right? So these are permanent magnet motors, so what's happened is the motor became seized with inside the magnets and it's not going to allow it to operate at all. Right? You're not going to get a high resistance in between the lines here, so your resistance is probably going to be inside the motor, so you'd actually have a failed component in that part, so you would have to replace this motor. All right? This is the motor that runs your forward and backwards because this is where your cable goes from the two gears at the bottom. Right? Your other motor is for the seat tilt, and the other one's for the seat rise up and down off the floor. All right? So each motor, two components, all right? So six-way seat. Forward and backwards, up and down, tilt forward, tilt backwards, six-component seat, all right? Now we have high resistance in this line on one side, but not on the other side. Your failure would be here. If resistance was on this side, then your problem would be with inside the switch, and this is where your component would be failed, and you'd probably have to put a new switch in on the side of the seat. Here, take the seat out and do the motor. Do not try and do the seat motors while the seat's mounted to the floor. It's pretty tight and congested. There's a good chance you're probably going to break something. Depending on the vehicle you're working on, you could have airbag seats. You could trip an airbag sensor in the seat and blow somebody's airbag. So it's always best to unhook everything, remove the seat, and go from there. Okay? All right, I hope everybody understood that, and I'll be back in a little while for a second video.